guys, this is for Unit 1, Lesson 12. So the beginning of Unit 1, which we did prior to data, was all about two-dimensional geometry. Now we're going to take that flat, that two-dimensional geometry, and we're going to turn it into some three-dimensional geometry. So today we introduced the idea of surface area. So we watched a video in class where they took some Post-it notes and they covered the entire cupboard with Post-its, right? So they chose the square ones because we cover area in square units. And sometimes we write out the words square units, square centimeters, square feet, things like that. Sometimes we write it as units squared. But this is representing, again, that two-dimensional geometry we have. When we talk about surface area, we're not talking about one shaped area. We're talking about a three-dimensional object, right? And the area of all of its surfaces added together. So if you think about a present that is wrapped, surface area would be how many squares of wrapping paper do you need to cover the top, the bottom, the front, the back, the left, and the right sides. So when we think about right rectangular prisms or cubes, shapes that we've had a lot of experience with, they usually have 6 surfaces: top, bottom, front, back, left, right. You have to calculate the area of all of them, and all of them are just rectangles, right? We have formulas for the rectangles, and then we're adding them all together. On your homework tonight, you're being asked to calculate the surface area of the rectangular prism. Now, on homework like this, it looks two-dimensional. So remember, this does have a top, a bottom, a front, a back, and a left and a right, but we just can't see all of those sides. Then it's asking you really this definition here. And then down here, you would have to figure out the area of both of them, and it's asking you which one has a greater surface area. So which one would take more squares to cover the outside. Good luck on your homework.